Good afternoon, class. So this one is calculator sections. Just want to demonstrate the way to apply that, how to find the linear regression on a TI-84, or you can do that on any kind of a TI graphing calculator. And this one is for calculus section 1.2, and it's not just for linear regression, but also it's for like exponential regression. So I'll do two examples, the way to using the TI-84. So first thing that you want to do, so you want to set up the data. So we'll talk about one of the problem. It's about the number of year versus the height. So if you go to stats and then you go to edit, so first edit, and then you see two column here. So list 1, list 2. The rest of the column, don't worry about that because we just want to use that the independent and the dependent variable. So L1 is just like the time or the X column, and then L2, then that'll be the Y column. So what I got for the data, so started in year 1900, so instead of putting 1900 I put in 0, so 0 year. And then the next one is 1904, so 4 years later. And then after that 8 years, 12. So you see the increment here is by 4, so the next one would be well, it's not the consistent increment, so the next one would be 1920. So I need to put in 20 for that one. And then 24. And then 28. And then 32. 36. So that would be 1936. And then 48, 1948. And then 52. Okay? And now for the L2 column, so all the way back to the original, all the way to the top. Whoops. So for L2, so the first height in year 1900, so then that'd be 10.83. So this one is one of the problems for the Olympic game, you know, people that breaking the world record for the pole vault competition. And then the other one it's 11.48. So gotta be careful the decimal that you put in. And then 12.17. See that as the year, the time is getting close to the present year, and then you know people are making the higher. So those are the world record for all those years. And then 12.96. 13.42. And then 12.96, 13.77, 14.15, and then 14.27, 14.10, and then this one in 1952, and the world record it's 14.92. So now once you put in all the data, so you can go to second stat plot, and make sure that this one got to be on, it's not off. So mine is off right now, they're all off, so now you want to turn it on. So go to press 1, and then see that the one that's blinking here, so you want to turn it on, so press enter. And now once you convert that to on, and then I would like to go to stats. So well, instead of going stat, you can go to zoom, and then for number 9 here you see that zoom stats, so that's what we want. So zoom stats 9. Okay, so here's the data. Do not worry about the curve. The curve is just the extra stuff that I have, so I'm going to delete that one. So go to y equal and then clear that. So one more time, zoom, and then 9. So you see that the bunch of scatter plot. So this one, and according to the instruction, so that's what we did. Make the scatter plot and decide whether a linear model is appropriate, and then find a graph of the regression line. So the next thing that we want to do, so we want to go to stats and then calc, because we want to find out the linear regressions model. So you want to go to number 8. And for those you might be wondering, can I use number 4? Yes, you may, because that one is for, let's say that you started with 0, but anything that you started with like a non-zero is better for you to use linear regression for a plus bx. So press 8, and then you want to go to calculate, and then press enter. So this one shows the model for the linear regression. So for the slope, it's about 0.0679. 5, or we can round it up to 2 decimal places, 0.07, so 0.07x plus 11.6, or 11.55. So we just put it back in here. So 0.067x plus 11.55. So this one is going to be the linear regression. So you want to go to zoom and then press 6. Now this one is not going to show you anything because that the y-intercept is kind of all the way up here. So now you want to go back to zoom and then 0. So that's just give you the model for the line. And now you want to see that it's connected with the scatter plot. So you want to go to zoom and then hit 9 again, and here we go. So here's the linear regression model. So now what about, let's say that you want to do something with considering the exponential regression. So here's another problem. So let's say that you're talking about like a population growth or anything that's considered like bacteria decay. So that would be considered like the exponential model. So here's one of the problem. Again, so we'll change the data. So go back to stats, add it, again L1, L2. So this time we do have a year of 1900. So again, started with year 0, and then looks like the increment, it's every 10 years. So the next one I'll put in 10, 20, 30. Again, this one is one of the problem I'm checking at. It's on page 37 for the James Stewart calculus book. It's a section 1.2. And then the next one I'll put in 40, 50, so on and so forth, 60, 70, so that means 1970, and then 80, and then 90, and then 2000. So 2000, this one you want to put in 100. And then for the L2, you want to put in the population. So the unit would be million people. Okay, again, that's going too much. Okay, so starting the initial year, 1900, so the population is 1,650 million. 1650. And then the next one is 1750. 1750. And then 1860 for the next 10 years. And then 2027. 2300. Again, this one is the given data sets from the problem already. So what I'm doing right now, I'm trying to generate all the data, so we can just put in to the exponential regression model. And then the next one is 3040. And then 3710. That's a lot of number here. And then the one after that, 4,450. Again, there's no any kind of consistent increment here. Well, because that's the exponential growth model. It's like a random exponential growth. So the next one is 5,280. And then 6,080. So now let's check this. So we got all the data, L1, L2, so like an X column, Y column. So now you go to zoom. Again, hit 9. As you can see the model here, it's like exponential growth. It's a curve. So no longer to be a line right here. It's a nonlinear exponential growth model. So in order to find out the exponential growth model, you want to go to stat once again. And you want to go to calculate or calc. And what we got here, it's linear regression, quadratic regression, cubic regression, and the quartic regression. And the one that we're looking for is called exponential regression. So what you need to do, you want to scroll it down all the way. So we got the natural log regression for number 9. 0, that's the exponential regression. So now let's see any other selection we have. And it looks like the exponential regression, that's the one we need to apply. And it looks like we do have a power regression. Logistic, we're not using the logistic yet. Sine. Okay, so let's use that, the exponential regression. 0, so press that. Again, go all the way down to calculate. And then simply press enter. And here's where we go. So that's the model. So we got y equals a times b to the power of x. So a is the scale factor, b is the base, x, which is the exponent. And what we got here is 1441.6 times 1.01 to the power of x. So I'm going to write this down and then put it into the y equal for the functions, the exponential model. So we got y equals 1441 times 1.013. Perhaps you can round it up to 4 decimal places. So 1.0138 to the power of x. Okay, so I'm going to put this in to y equal. So clear the previous one. So we got 144. Again, 1441, that's just the initial population in the year of 1900s. And then multiply by parentheses 1.0138. So this one is just 1 is just considered 100%. So the rate is actually about 0.0138, and then to the power of x. Again, we go to zoom, hit 9, and here we go. So as you can see that the dot, it's going along with the curve. So this one is the exponential regression model. Okay, so I hope that you enjoyed watching this video. Thank you.